Welcome back to Physics with Miyoshi. We're here today to talk about a little bit about fluids and a little bit about Archimedes' principles. Archimedes said that the Archimedes principle says that the magnitude of buoyant force equals the weight of fluid the object displaces. Well, what does that mean? Well, if I have a ball and it displaces a certain amount of fluid, this air in this room is fluid, and so it displaces an amount of fluid. Well, that fluid could be over here, and it would be the same shape and the same size, but it would be obviously a different weight. But if that weight of that fluid displaced is greater than the weight of the object that's displacing it, then that object will float. So if the air was actually weighed more than this ball, the ball would float instead of sinking. Now, so since this ball weighs more than the air that is displacing, then the ball will just float, or will sink in this fluid of air that we're in. If it was water, the same thing would be true. If I had the same volume of water as I have ball over here, then this guy would float because this ball weighs less than the amount of fluid that it would displace. So when I put it in the water, it will actually float. And that's what Archimedes' principle kind of shows us, and that is that when it comes right down to it, if the weight of my fluid displaced by my object, is greater than the weight of the object, then the object will float. Another way to say that is, if the density of the object, so my object that I want to float, is less than the density of the fluid, then the object will float. So if the density of this ball is greater than the density of air, it's going to sink. But if the density of this ball is less than the density of water, or the density of air for that matter, then it will float, whether that's in air or water or any fluid for that matter. It does come back to the same little picture over here, but let's explain a little bit more. So if I have any object, even this funny looking shoe, if I have this shoe as an object, I could try to make it float, and it might float in water, and it's not going to float in air, but it might float in water. And the way I would know that if it's going to float in water, or any other fluid for that matter, is I would take it and submerge it, and I'd stick it in the water, and I'd find out how much water, or how much other fluid, it's going to get displaced by this guy. And then I would weigh that water, and if it weighed more, or that fluid, if it weighed more than this guy, then this will float. And if it weighs less than this guy will sink. So, that is Archimedes' principle in a nutshell. We can look at it, there's a couple other things. The buoyant force is actually the upward force multiplied by the area. So if I have my little shoe boat here, I would have the area of the bottom, and it's the upward force that my fluid, in this case my air, is exerting on it, is the buoyant force is whatever pressure multiplied by that area, and that would give me how much buoyant force is going up. Well, in this case, the pressure, or the force that's pushing up, is smaller than its weight component, so we know that it's going to, from Newton's second law, we know that it's going to fall. We can also write that another way. The buoyant force is the pressure, the lower pressure, which is going to give us resultant force up if we multiply it by the area, minus the pressure on the top, and then multiply that by the area, and that's going to give us our buoyant force. Again, the way we want to look at this, if we have a volume of some sort, whether that is a rectangular volume, or a shoe bottom, or a spherical, whatever that happens to be, whatever the shape happens to be, I can find my buoyant force by rho times g. If it was rectangular, a rectangular prism, I could have it the h times the a. A is the area of the surface area of the bottom. H would be my height. So this would just be rho times g times the volume. Gives me my buoyant force. So, just a little bit more about fluids, and a little bit more about pressure, and a little bit about this thing called Archimedes' principle. With Archimedes' principle, we can decide whether an object will float or sink in a fluid just by knowing its density. We can look at that. We can know it by finding out the weight of the fluid that it displaces, and then we can decide whether the object is going to float or sink in whatever fluid we want. It doesn't have to be air, it doesn't have to be water, it could be something like mercury or any other fluid that you can think of. So, that's it. And I'm sure there's lots more, and I've just touched on the surface about fluids, but here's Archimedes' principle in a nutshell. Find out if you can determine whether you can make a boat that will float or sink, and you can make boats out of lots of different materials, and they will sink or float depending on how you make them, depending on Archimedes' principle, and what a wonderful principle it is if you are a boat builder. So, thanks for tuning in. We'll see you next time for more Physics with Miyoshi.